Here is the solution to the James Roos High School 1993 trial paper question 10b. Once again, if you haven't seen this question before, you should try it before you watch the remainder of this solution. There's a couple of really important things going on here, well worth looking at. And beginning with the interpretation of the question, here's our diagram which was given for the first 20 seconds of flight. Its angle of elevation, theta, changes at a constant rate of 2 degrees per second. So, part A, find theta as a function of t. Now, this is right from the beginning, this is a challenging interpretive question, because what we see down here, this part down here, during the first 20 seconds, the missile is travelling at 2 degrees per second. Now, 2 degrees per second, that is a velocity. And what we know is the velocity is a rate of change. And it's a rate of change of theta. Theta is changing over time, constantly in this case. So the first part of accessing question 1 is recognizing that we're working with a rate of change. And if we've got d theta dt equals 2 degrees per second, then theta is its integral with respect to t. So we get 2t degrees plus a constant. And when t equals 0, we know initially it's at, when t is equal, there's no angle. Okay, so we can prove that c equals 0, which you must do. So theta is 2t degrees, where t is obviously time in seconds. And that is a function, find theta as a function of t. So that's how we introduce a t, because we're integrating with respect to t. Hence, express the distance travelled by the missile as a function of t. Okay, now distance is this bit here, which is x. We've got an expression of theta, right? And we've got this distance here of 10, so I'm going to use a tan ratio to start this. So tan theta equals that, and we get that expression. And when theta equals 2t from part 1, okay, I can substitute that in, because again I'm asked to find it as a function of t. This is not t yet, and so I get x equals tan 2t. Now this however, the 2 is in degrees, or the 2t is in degrees. We are trying to measure distance, and this is, I suppose, the second really important part of this question. We have to recognize that we're working in degrees, we're trying to find distance, so we have to change it into radians. The 2, obviously t can't change, but the 2 can. And we have, I'll show you down the bottom here, the 2, let's say there, that 2 is degrees. So just by conversion, okay, pi radians is 180 degrees, 1 degree is that, so 2 degrees is pi 90. So our expression, because it's really invalid to leave it as 2, because 2 degrees doesn't measure distance, so we put it in terms of distance. X is 10 tan that. Okay, and that is the full answer for part 2. However, as we move to part 3, we're going to have to be able to move both in terms of degrees and radians. Find the velocity. Now velocity, right, if we've got distance x, then velocity is, as I've got up the top here, velocity is the derivative, or x dot. And we're also given that the angle of elevation is 30 degrees. So theta is 30 degrees, or 2t is 30 degrees, because 2t we found from part 1. And I'm going to have to use this in a moment. Okay, so we differentiate 10 tan, the derivative of tan is sec squared, and then we multiply by the derivative of the bracket, which is pi on 90, with respect to t, so it's pi on 90. Now, simplifying, I just bring the pi on 90 over here, so 10 on 90 is just that. And here is where we have to really be alert to what's going on. Sec squared, with respect in degrees, comes back to 2t because I have to evaluate sec squared. Now I can't do that with respect to this. I have to do it with respect to degrees. Now cos of 30 degrees is root 3 on 2, so sec is 2 on root 3, and sec squared gives me this number here. So that's a really tricky step, which gives me this. Now don't forget, we're still working in kilometers per second, so times by 60 to give minutes and 60 to give hours gives me a final answer of 1600 pi on 3 kilometers per hour. Okay, but really it gets pretty tricky in here, where we have to move from that, which is a measure of radians, but why do I go back to degrees? Because the question is giving me degrees. But had I left that as 2t and then found the derivative, I would get, instead of this whole thing here, I would get 2 times 10. Now again, we have to work in pi because it's a distance measure at this point here, right? We're measuring with respect to distance, but we've been given an angle in terms of degrees. So I put it back in terms of degrees, and that's why I can substitute 30 back into the sec squared. Okay, so I'll just zoom back out to the full solution. So a number of tricks here just to be aware of. First one was understanding rate of change and where we start this question. Understanding in part 2 that distance has to be changed from 2 degrees into radians, which gives me this expression. And then part 3, although I start in radians to measure velocities or speed, not speed, to measure velocity, I have to evaluate sec squared with respect to the degrees because I'm given degrees here. And answer, don't forget you leave your answer in terms of pi. And just again, giving your answer in terms of kilometers per hour, just be alert to these couple of things as you go through. So another tricky question from, of course, James Roos High.